Hello, my fellow mathematician. Welcome to our study, Calculus 1. I want to take you through Calculus 1 in 1 hour. We are going to look at methods of differentiation. The first one we are going to consider is by definition, by power rule, by product rule, implicit rule, quotient rule, chain rule, exponential rule, logarithmic rule, higher order derivative, maxima and minima. And then we are going to look at the special functions which are called transcendental functions. These include trigonometric function, logarithmic function, and exponential function. And finally, we are going to look at the application of differentiation to kinematics. So welcome, we learn together. So x squared, and by definition, a prime is given by limit as a change in x tends to 0 of this function. So we take 2 points. So we shall take these 2 points, x from this function, x squared is the second. Then we take a small change in x. The y1 will be x plus change in that. And then we apply the definition there. So we apply the definition of derivative, which is limit as delta of 10 to 0, and we substitute this. This is y, change in y, this one, over change in x. So this part here minus the other one. Then we expand this part in bracket to get. So expanding this one, we are going to get this. When we expand this part here, we are going to get x squared plus 2x, change in x plus change in x squared minus x squared. So here x and x will cancel. X squared will cancel with minus x squared to get. So we are going to be left with this. Here we can factor change in x outside to get. So factoring change in x here, we are going to get this. Now you can see now we can cancel change in x here to get the following. So after cancelling the denominator, this one, with the change in x, the small change in x, we are going to be left with the 2x plus change in x. So as change in x tends to 0, this part will go to 0. This section here, this one goes to 0, and we are left with 2x. So that is how we obtain derivative by definition. You simply pick any 2 points, and then you use the definition, and you obtain your answer as simple as that. The next one, it is the power rule. Our part 2, we want to look at power rule. Power rule as method of differentiation. So in order for you to understand power rule, we are going to apply these rules of algebra. When you are given a power n times a power m, the result is a power n plus m. When you have a power n times a power n, the result is a power 2n, because n plus n is 2m. When you have a power n divided by a power m, the result is a power n minus m. When you have a power n divided by a power n, the result is a power n minus n, which is equal to a power 0. Any number power 0 is 1. When you have a power negative 1, the result is 1 over a power n. When you have 1 power 1 over n, it means we find nth root of a. When we have a power n power m, it means m root of bracket a power n, or you take the m root and you multiply by n. So these rules from algebra, we are going to apply them in the power rule. We shall consider these two possibilities where you have function of x as x power n. From the power rule, the derivative is simple. You simply bring the index in front of x and you multiply by x, then you reduce the index by 1. When you have function as a x power n, so the derivative is n times a, then the index reduced by 1. When you have function as equal to constant, it can be written as c power x power 0. I mean c times x power 0, because any number power 0 is 1. So you drop the index, you multiply the constant, and you reduce the index by 1. So any number multiplied by 0 is 0. So the derivative of a constant is always 0. You note that. And finally, we are going to consider the polynomial. Polynomial of this form. Here, a, b, c, and d are a constant. So what is done here, we differentiate term-wise. So this term is differentiated independently. So that is why we are going to get n here. X, n times a, you reduce the index by 1. This way. The other one, n minus 1, reduce the index by 1. So n minus 1 is minus 2. The other one, c, x power n minus 2. So you multiply by the index n minus 2, and you reduce the index by 1 to get negative 3. This other one, you multiply by 0, reduce the index by 1, so 0 minus 1. So we want now to look at the examples. Examples. We are going to start with the example of this form here. So example, given function is equal to this one. So the derivative is very simple. F prime of x, you just drop the power, which is 4, times x, reduce the index by 1. So you have 4 minus 1, which is equal to 4 x power 3. So that is the derivative of that function. Example 2. Example 2, you are given your function as y is equal to 2x power 5. So the result is y prime is equal to 5 times 2. Then you have x power 5 minus 1, which is equal to, so 5 times 2 is 10, x power 4. So that is the result, the y prime. Example 3. Example 3, now we have function of x is equal to 6. This can be written as 6 multiplied by x power 0, because any number power 0 is 1. So using the power rule, you just drop the 0 in front of x, you multiply, you reduce the index by 1. So any number times 0 is 0. So that is how you do the derivative in a easier way. So number 3, we look at the number 4, we look at now the polynomial. When you are given the polynomial. So you are given this polynomial. So to get the derivative f prime of x, what you do is that you differentiate this term-wise. So 2 differentiated, you have 2 times 2, which is 4. 2 minus 1 is power 1, plus, here you have 1 times 3 is 3, x power 0, because of 1 minus 1, it will be x power 0, which is equal to 1, plus 0, which is equal to 4x plus 3. So that is how we differentiate the function using the power rule, as simple as that. The next, we are going to look at the product rule. Number 3 of our method of differentiation, it is the product rule. We are going to let f of x and g of x to be 2 functions which are continuous. Hence, if they are continuous, it means they are differentiable. So f of x is equal to u, f prime is u prime, g of x is equal to v, and then g prime is v. So the product rule tells us that if you are differentiating 2 functions which are being multiplied, then what you do, you differentiate the first function as you keep the second function constant, plus now the first constant, plus the first function being a only constant, you differentiate the second function. So which can be written as u prime, which can be written as u prime b prime, meaning that the first function differentiated, the second kept constant, plus the first constant kept constant, the second differentiated. So we are going to give a simple example to bring this point home. So we have this here, find the derivative of this function x squared plus 2x multiplied by sine of x plus 2x plus 1. So we are going to use product rule by let our u be equal to x squared plus 2x. Then it means that our u prime will be equal to 2x plus 2, differentiating this. Then we let our v be equal to sine of x plus 2x plus 1. So our v prime will be, when you differentiate sine, it will give us cos of x. When you differentiate 2x, it will give you 2. So that is it. Then from there now we apply the rule. We apply our rule. U prime multiplied by v plus v prime multiplied by u, which is equal to, so we substitute u prime is 2x plus 2. That way, we multiply by our v is sine of x plus 2x plus 1. This one here. This one. Then plus our u, this formula, our u prime is x squared plus 2x. Then we multiply by our v prime is cos of x plus 2. So when you look at this, it cannot be simplified further. So we can leave it at this point. So that is how we apply the product rule to give us our result. So all what you have to do is when you have two functions, let those functions be u, you differentiate u, the first function to be u, then let the second function to be v, differentiate v, then you apply this formula which says the first function differentiated multiplied by the second. So our first function differentiating, it is 2x plus 2. Our second function, it is sine x plus 2x plus 1. Then plus our second function is x squared plus 2x multiplied by our second function kept constant, which is multiplied by our second function, differentiated v prime. When you differentiate sine x, it will give you cos x plus 2. Our next method will be quotient rule. Method number 4 of differentiation is quotient rule. So we are going to consider function f of x as equal to u, f prime, u prime, g, v, g prime, v. So these two functions are continuous and differentiable. So when you are differentiating f of x over g of x, you differentiate the first function, then you multiply by the second function. You subtract the first function multiplying by the second function differentiated, then you divide by the square of the second function. So here the order matters. So differentiate the first function multiplying by the second function, a odd constant. Subtract the product of the first function multiplied by the derivative of the second function. Then you divide by the square of the denominator. So that is how you apply product rule. So we give a simple example to bring this point home to you. So you have the example here. You are given y is equal to 4x squared plus 3x divided by tan x plus 1. So you are to find to y prime. So what we do here, we are going to let the numerator be equal to u, which is equal to 4x squared plus 3x. Then differentiate it will be u prime, which is equal to 8x plus 3 when you differentiate this function. Then part 2, you let the denominator to be v, which is equal to tan of x plus 1. Differentiate this with respect to x, it will give you sec x squared plus 0. Then you apply the rule, the quotient rule is here. We apply this quotient rule. So our y prime is equal to u prime multiplied by v minus u v prime divided by v squared. So you substitute, our u prime is 8x plus 3. You multiply by our v is tan x plus 1. Then you subtract, our u is 4x squared plus 3x plus 3x. Then you multiply by our second function, which is the denominator differentiated, our v here. Our v differentiated is sec squared x. Sec squared x. Then we divide everything here by the denominator, which is v squared. We divide by tan of x plus 1 and we square. So that is how we apply the quotient rule. You simply let the denominator to be u, differentiate u with respect to x to get 8x plus 3. Let the denominator to be v, which is tan x plus 1, differentiate it to get sec squared x plus 0, which is sec squared x. Then apply the rule u prime multiplied by v, here 8x plus 3 into bracket tan x plus 1. Then multiply by the second function differentiated times the first function the way it is. Then you divide by the first function, the second function, which is the denominator squared, this way. So you can leave your answer at that, or if you want, you can even simplify. So that is how we use quotient rule to differentiate. What is important is to note the order. The order matters here, so that you don't make the error as you differentiate. So I hope this was helpful. Next time we are going to look at chain rule. Chain rule will be our next method of consideration. Our number 5 area of consideration or method of differentiation is chain rule. Here you have function y, which is a function of u, and the u is a function of x. So to differentiate, what you do, you differentiate function of y with respect to u to get L prime of u, then differentiate function of g with respect to x to get g prime of x. So here we are going to have dy and dx is equal to du dy and du multiplied by du dx. So that is what you do. If you are given the three function, which is a function of a function and a function of a function, you do the same. So let us look at an example. Find y prime given. So find y prime given that y is equal to bracket 4x squared plus 3x plus 2 power 3. So what we are going to do, we are going to let let our u be equal to 4x squared plus 3x plus 2. So that is our u. Then our y will be equal to whatever is in bracket here. We substitute it with our y will be equal to, so whatever is in bracket here, it is u cubic. So our interest now is to get du dx, which is equal to u prime. Here, this will give us 8x plus 3. Our dy over dx will give us 3u squared. Then from there now, we substitute in this formula. We are going to have our dy over dx is equal to, our dy and du is, dy and du is 3u squared multiplied by our du and dx is this one, 8x plus 3. This is equal to 3 into bracket. Instead of u, we write this 4x squared plus 3x plus 2 squared times the other part is 8x plus 3. This can be simplified. 3 times you can have 3 into bracket 8x plus 3 multiplied by 4x squared plus 3x plus 2. So that is how we apply chain rule to obtain derivative in a very few step method. We can obtain our result here by the direct method, whereby you drop the index, which is 3. Then you keep whatever is in bracket constant, 4x squared plus 3x plus 2. That is a plus here, plus 2. Yeah, plus 2. You close the bracket and you reduce your index by 1. So 3 minus 1 is 2 times you multiply by what is inside the bracket differentiated. So 4x squared differentiated will give you 8x plus 3x differentiated will give you 3. 2 differentiated will give you 0. You close the bracket. And when you compare this, it is the same. 3 into bracket 8x plus 3 into bracket 4x squared plus 3x plus 2 squared. So chain rule can be, there is a square here. Sorry. So chain rule can be applied directly and you are going to get the same result. Another example, if you have y is equal to sine squared of 2x. So to solve this, you let u to be equal to 2x. Your u prime is equal to 2. Then your y is equal to sine squared u. So our y is equal to sine squared u. Our y prime, you bring 2 forward, 2 cos of x, then you multiply by sine of u. So here times sine of u, which is equal to this multiplied by sine of 2x. So that is our result. This could have been obtained directly by bringing 2 down, then you multiply by 2 sine 2x. You reduce the power by 1, then you differentiate that times cos of 2x multiplied by 2. The result will give you 4 sine of 2x cos of 2x, which is the same as the value which is up here. So that is how we apply chain rule to solve the problem in a easier way. So you let this value to be 2x, then u prime is 2, y is sine squared u. You apply the power rule here, whereby you drop the 2 down, you keep this, you reduce this by 1, and you differentiate this. Sine differentiated is equal to that, and your value will be this one as shown there. The next method we are going to look will be the implicit differentiation method. Implicit differentiation. So to differentiate this, first of all, we make y the subject of the formula. So we are going to have y squared is equal to 25 minus x squared. We take square root, so y is equal to 25 minus x power half. So y prime is equal to half 25 minus x squared power negative half, because it is a minus 1 multiplied by negative 2x. This gives you power half multiplied by negative 2x into bracket 25 minus x squared power negative half, which is the same as negative x divided by square root of 25 minus x squared. So there is a situation whereby now it is not possible to make y the subject of the formula. In such cases, that is when now we make use of implicit differentiation. For example, if you have 4x squared plus y squared is equal to 2xy plus 5xy cubic plus 2x. In this scenario, it is not easy. Actually, it is not even possible to make y the subject of the formula. A case like this, that is where now we require the implicit differentiation. So implicit differentiation works this way. This will give us 8x plus 2y. Because we are differentiating with respect to x, so we multiply by dy dx y prime, which is equal to, here this is a product rule. We differentiate x as we keep y constant, plus we differentiate y as we keep x constant. So it will be 2x y prime plus 5y cubic. We are differentiated x and we have kept y constant. So we differentiate y cubic as we keep x constant. So it will be 15x y squared y prime plus 2 when we differentiate that. So what we do at this level, you group the terms with y prime. So we are going to have 2y prime minus this one, 2x y prime minus this other one, 15x y squared y prime, which is equal to, we take this 8 to the other side, 8x plus 2y, this one, this 2y plus 5y cubic plus 2. So we have picked this the other one, and this. And we have taken 2xy prime this other side, and we have taken 15x y squared y prime on the other side. So the next thing what you do, you factor y prime on the left hand side. So factor y prime to be left with the 2y minus 2x minus 15xy squared, which is equal to 8x plus 2y plus 5y cubic plus 2. Then the next thing, you divide both sides by whatever is in the bracket to be left with y prime, which is the same as dy over dx is equal to 8x plus 2y plus 5y cubic plus 2x, this one. We divide this by 2y minus 2x minus 15x y squared. So that is how we use implicit differentiation to obtain our result. Even this equation here, we can use implicit differentiation to obtain the same result. So let us see, whereby we have x squared plus y squared is equal to 25. So this one will give us 2x plus 2y dy dx, which is equal to 0. We can take 2x the other side, so we are going to be left with 2y y prime, which is equal to negative 2x. We divide by 2y both sides, y prime is equal to negative 2x over y. So dy over dx is equal to negative 2x divided by, now this is 2y here, sorry, 2y. So there is 2 here divided by, from here, our y is the same as 25 minus x squared power half, which is the same as negative x divided by 25 minus x squared power half. The same result we obtained here, minus x over that. So we apply, that is how we apply trigonometric, that is how we apply implicit differentiation when it is not possible to separate values of y, when it is not possible to make y the subject of the formula, like in this case here. So thanks so much. Application of implicit differentiation in determining derivative of inverse function, trigonometric inverse function. So given y is equal to sine inverse of x, we multiply by sine both sides to get sine y is equal to x. So we are going to consider a right angled triangle, whereby now sine of y is given by opposite over hypotenuse. So this is hypotenuse. So our opposite is x. Our hypotenuse should be 1. So that now we should be 1. So that when we divide x divided by 1, it will give us x. Now we can get the adjacent by applying a Pythagoras theorem, which is 1 minus x square root by Pythagoras theorem. So we differentiate this one here. So sine y differentiated will give us cos of y dy dx. But now because it is an implicit function, we multiply by dy dx, which is equal to x differentiated is 1. So we divide by d by cos x both sides, which is equal to 1 over cos of y, which is equal to, but we know that cos y from this diagram is given by adjacent divided by hypotenuse, which is equal to, our adjacent is 1 minus x squared square root, everything divided by 1 from here. So dy and dx is equal to 1 divided by square root of 1 minus x squared. So that is how we obtain the derivative of inverse function using implicit differentiation. For the derivative of other inverse trigonometric function, you can check in my channel whereby I have derived all of them. But simply that is what you do using implicit differentiation. So the derivative of sine inverse of x is equal to 1 divided by square root of 1 minus x squared. So it is as simple as that. Provided you follow the rule, you obtain your answer with ease, as we have done there. Our next consideration will be the exponential differentiation. So stay tuned. Derivative of exponential function. So these are the rules. Y is equal to exponential x. Derivative remains the same. Y is equal to a power x. A is a constant. It is ax ln of x ln of a. Y is equal to logarithm of x a. It then becomes y prime is equal to 1 over x ln of a. Y is equal to exponential function of x. So you differentiate function of x and you multiply by exponential that function. And finally, you have ln of a f of x. So it is that f of x differentiated over ln of a multiplied by f of x. F of x. So that is what is done. So we are going to have an example to see how these are done. So we look at this example. We are to get the derivative. So solution for number 1, y prime will be equal to exponential x because it remains the same. Part 2, y prime will be equal to, you differentiate 2x squared will give 2x squared will give you 2x multiplied by exponential x squared. Roman 3 a power x. So y prime will give us a power x ln of a. So as simple as that. Roman 4 y prime will be given by 1 over x ln of a. Number 5, y prime is equal to, we differentiate this function, so you have x plus 1 differentiated will give you 1 divided by that function, which is x plus 1, then natural logarithm of a. So that is how we obtain derivative of exponential function in a simple way. So the exponential remain the same if it is just power x. If it has x squared or any other function, you differentiate that function this way. This one, it is this result. Ln of x, it is that one. So next time we are going to look at logarithmic differentiation. We look at next logarithmic differentiation. So we want to find the derivative of this. So we are going to apply this rule. Ln of bracket a over b is equal to ln of a minus ln of b. Ln of b. So ln of a squared is equal to 2 ln of a. So ln of a squared is equal to 2 ln of a. Ln of a power n is equal to n ln of a. So these are the rules we are going to apply here. So we begin by first of all taking logarithm in this equation both signs. So we are going to take logarithm both signs, both the left hand side and the right hand side, to obtain ln of y is equal to ln of. So we apply this rule because here we are dividing. Our a is this one, bracket x squared plus 2x power half minus ln of our b is 3x plus 4x plus 1 power 3. So we have applied this rule. Then we apply this other rule, a power n. Our a is whatever is in the bracket. Our n in the first case is power half. So we can bring power half in front of the logarithm. So which is equal to half ln of bracket x squared plus 2x minus, we bring 3 in front here, minus 3 ln of 3x plus 4 plus 1. So we are also going to apply this rule which tells us that if you have y is equal to natural logarithm of a, then y prime is equal to 1 over a. And if you have y is equal to ln of x, then this is y prime is equal to x prime divided by ln of x. So that is the rule we are going to apply here. So in differentiating both the right hand side and the left hand side. So here we are going to get 1 over y prime. This sign is implicit differentiation. So y prime, which is equal to a half bracket x plus 2x times, we multiply by this differentiated, so you have 2x plus 2 minus 3 multiplied by 3 there is x here, multiplied by 4. This is 3x, 4x, yeah. Then we divide by, note that this can be written as 7x, so divide by 7x plus 1. This is 3x plus 4, so it can be combined that way, which is equal to, so here we can factor 2 into bracket x plus 1 divided by 2 into bracket x squared plus 1. Oh, sorry, denominator it is x squared plus, the denominator it is x squared plus 2x, this one, x squared plus 2x minus, this is 3 times 3, which is 9 times 4. You have 9, you have 7 times, this is 36 divided by 7x plus 1. Then finally what we are going to do, we are going to multiply by y in both sides. So y prime will be equal to 2 into bracket x squared plus 1 divided by 2 and 2 will cancel, sorry, this 2 and 2 can cancel there, divided by x squared plus 2x, x squared plus 2x minus 36 over 7x plus 1 multiplied by everything there multiplied by y. Y prime is equal to this x squared plus 1 divided by x squared plus 2x, this one, minus 36 divided by 7x plus 1 into bracket multiplied by y. Our y is this value, so you multiply by that. So x squared plus 2x, this one, everything into bracket power half divided by this 3x plus 4x is the same as 7x. 7x plus 1, everything power 3. So that is our result, and that is how we differentiate logarithmic function. So it has 5 steps. Step number 1, you take natural logarithm both sides, both the left hand side of this equation. Step 2, you apply this rule. Ln of a over b is the same as ln of a minus ln of b. Then you apply this other rule. When you have ln of a power n, it is n ln of a. You apply it the way I've applied it here. Then you differentiate, whereby now you differentiate this part to be 2x plus 2 over the function the way it is, minus this part differentiated over that, and then you simplify as shown here. So that is how you obtain your logarithmic differentiation. And you then once you are at this level, you multiply by y in both sides, then you substitute the value of y. Our value of y is this part here, so you can leave it at this point. That is how you obtain your differentiation in those few steps method, and you are able to get your value. So the next time we are going to look at higher order derivative. Parametric equation differentiation. So we are going to consider x is equal to function of t and y is equal to function of g of t. So to differentiate, you have dx with respect to t is f prime of t. You have dy with respect to t, which is equal to g of t. So dy over dx will be given by dy over dt, this one, dy over dt divided by dx over dt, which is the same as dy over dt multiplied by dt over dx. For example, find dy over dx given that x is equal to x of t is equal to 5t, and the y of t is equal to 64t minus 16t squared. So first of all, we are going to get dy over dt here. So when you differentiate this with respect to t, we will get 64. 16t squared differentiated, we will get 32t. Dx over dt is 5. Then we apply our formula. Dy over dx is equal to dy over dt divided by dx over dt. So our dy over dt is 64 minus 32. Minus 32t divided by 5. So that is the answer. Next, find dy over dx given that x is equal to a cos of a and y is equal to a sine of sine theta. So x is equal to cos theta and y is equal to a sine theta. So you can follow the same procedure, you get, and you are going to get your response. From x is equal to a cos theta, we have dx over d theta will give us negative a sine of theta. Dy over d theta from here will give us a cos theta. So we are going to substitute here. Dy and dx is equal to dy and d theta divided by dx d theta. So we substitute and we substitute. Our dy and d theta is a cos theta divided by our dx d theta is a sine theta. So a cos theta over a sine theta is the same as negative cot of theta. So that is how we differentiate a parametric equation using step method, and you get your result. Thanks so much for watching this channel. Higher order derivative. Higher order derivative can be represented by all this method. Y prime means first derivative, second derivative, third derivative, fourth derivative, nth derivative. Or you can represent them in terms of f prime, f double prime, f third prime, f fourth prime, all the way to nth prime, or dy and dx, d squared of dx squared that way all the way to the last, or this way. So we want to do an example given y is equal to x squared exponential x, find the fourth derivative. So we are going to use product rule. So example, we are given y is equal to x squared exponential x. So here we are going to use the product rule. Product rule tells us that you differentiate the first function, you multiply by the second function kept constant, plus first function multiplying by the second function differentiated. So you have left here u is equal to x squared, u prime 2x, v is equal to exponential x, v prime exponential x. So we substitute, we have x squared, x squared multiplying by exponential x. This second part here have begun with that. The other one, it is 2x exponential squared. Or alternatively, you can arrange them here this way. You write u as x squared exponential x, then differentiate this one that way and differentiate this one that way. Then you multiply the corresponding value, you don't get it, your answer as the same. Then from there now, y double prime means you differentiate this twice. So when we differentiate the first one, x squared exponential x, it is like this one here. So we are going to get x squared exponential x plus 2x exponential x by product rule. That is what we will obtain. Then plus we differentiate x differentiated is, it is 2 times exponential x, plus we own x constant, we differentiate exponential x, so we are going to get 2x exponential x. At this, you can check whether they are like term. We have 2 and this, so we have x squared exponential x plus 4x exponential x, combining 2x exponential x and the 2x exponential x plus 2 exponential x. So we differentiate this, y triple prime is equal to, when we differentiate this, we are by product rule, we are going to get x squared exponential x plus 2x exponential x. We want this constant and differentiate the second. We differentiate x squared to get 2x, we multiply by that, plus here it is 4 exponential x. When we differentiate x, we are going to get that plus We want the x constant and we differentiate exponential x, 4x exponential x. Then plus 2 exponential x. Let us see whether we have some like terms. Yeah, we have x squared exponential x plus we have 2x and 4x here, so we can combine that to get 6x exponential x plus we have 4 exponential x and 2 exponential x, so we are going to get 6 exponential x. Finally, y power 4 means that we differentiate this again, so we are going to get 2x exponential x plus x squared exponential x. This is by product rule plus. So what we do, we are differentiating x squared to get 2x exponential x. Then we are keeping x squared constant as we differentiate exponential. Here we have 6 exponential x plus 6x exponential x. That is holding x constant and differentiating exponential x to get that value plus 6 exponential x. We see whether they are like term. So we have x squared. Let me write it here. We have x squared exponential x plus 2x. There's this other one here. So we are going to have 8x exponential x plus we have 6 and 6, 12 exponential x. So that is the fourth derivative of this function we are given here. Our function is y is equal to x squared exponential x. So you do it step by step and you are going to obtain your result as we have obtained here. We want to look at now maximum and minimum point. We are going to consider this curve. So first of all, you differentiate it. This is differentiated, it will be 3x squared, 3 and 3 will cancel. This is 2 times 2, 4x which plus 3. So y prime is equal to 0. So we factorize this, and we are going to get x plus 1. X plus 3 is equal to 0. So x is equal to -1 or x is equal to -3. Now, from there now, we find the second derivative of this function. We obtain our second derivative of this. So this will give us 2x plus 4. So we find the value of 8 at x is equal to -1. So we want to obtain the value at x is equal to -1 of this. So this is 2 multiplied by -1 plus 4, which is equal to -2 plus 4, which is equal to 2. Now, since this one is greater than 0, then it means that so we get the value of y when x is equal to -1. So we are going to get negative around plus 2 minus 3 plus 1. So this is equal to negative around. So we have 1 of -1, negative around. So since here we have found that the second derivative of this function at x is equal to -1 is greater than 0, then it means point -1 and the negative around is a minima point. So this point is a minima point. So let us check the second point. So we want to check this point where x is equal to -3. So first of all, you obtain the value of y. So to substitute, we substitute here, y is -3. So this is -27 over 3 plus -3 squared is 9 times 2, 18. Then you have -3 times 3 is -9 plus that. So this is 7 divided by 3 is -9. plus 18 minus 9. So you see this is negative. This is 1. So we are going to obtain y prime of at negative 3. We see x value. So y double prime at x is equal to negative 3 is equal to, so we substitute here. So you have negative 2 times negative times 3 plus 4, which is equal to negative 6 plus 4, which is equal to negative 2. So this point here is less than 0, meaning that point negative 3 and 1 is a maximum point. So that is how you use calculus to determine whether point is a maxima. What you do, first of all, get the derivative. Once you get the derivative, find the value of at maximum point, the gradient is equal to 0. So equate this to 0 to obtain the value of x. Then get the second derivative, substitute the value of x at x is equal to negative 1. This is negative 2 plus 2, 4. Then because this one is greater than 0, then that means that one is a minimum point. Then go to the second one, you substitute the other value of x here. So you have 2 times negative 3, which is negative 6 plus 4. Negative 6 plus 4 is negative 2. So since this point here, second derivative is less than 0, then it means this point negative 3 and 1 is a maximum point. So that is how you use calculus to determine whether a point is a maximum point or a minimum point. Thanks for learning calculus 1 with me. Kindly you can like, share and subscribe to my channel at Luke Aaron 1 as indicated down there, so that you may continue learning maths with me. Bye bye.